Okay, I was talking about revising the design for the tidal generators, and this is more of a mix between if you know what a scramjet is, or kind of more like a kite. Actually, a lot more like a kite. I don't know if you call it aerodynamics if it's in the water, but there has to be some kind of, we're going to call it aerodynamics for now. Well, anyway, this is the main scoop. Then this is to funnel the current in. We have the inlets that go into the impellers. The impellers will spin, creating electrical energy, and then the exhaust will come out. Well, there are two sides for this, because we're going to build something more like a stealth bomber, and I'll show you the reason why. And the main reason why is I believe the the turbines will in the submarine design with the turbine in the center, the rotation of the turbine will cause issues. This is probably a lot more stable design. Well, anyway, we're going to enter the impeller here as well, and then exhaust. You have this fin, just like how you have in aerodynamics, how you would say a plane has fins. I'll show you the point of the fin for the tail fin in a minute. We also have side fins, and but the cool thing about this is this can rotate. This can be lying flat in the ocean, or it can be tipped on its side, but it'll work either way. I don't know which one's more efficient. I guess it would be depending on the current, but at least the fins can turn and lift and tilt depending on how the current to get maximum efficiency from the design. But here's the main reason. This main part here is the actual body of the generator, and this is the anchor to the ocean floor. Now, most of the current will be fed into the scoop, creating energy on the inside. It'll probably be tethered to a cable to the ocean floor, and just like how they'd use data cable, the old telephone cables, you can probably run telephone cable on the ocean floor, transfer the energy to the shore. The rear fin is because the way the current is pushed, there's a tendency for this thing to tilt down, and you don't really want that. You want if it works that, you can design this so it adjusts itself to get the maximum amount of power from the impellers. And if that means tilting it down, it means tilting it down. If it means tilting it up, tilting it up. If it means holding level. I'm not exactly sure how the ocean current works too much, but my guess is this has to stay somewhat pretty level to take advantage of the current. That is what the tail fin is for. As the current flows over, hugs the body of the generator, it'll go to the tail fin, and with the adjustment of the tail fin, whether it be down or up, can tilt the entire generator up or down. And that's your point of adjustment. Whether it tilts side to side probably makes not much difference. It won't affect the way it's closed. So the anchoring point could either be found at the bottom to hold this thing flat, or maybe pick a corner and invert the tail. Which I don't know which one would be better. A lot of testing would be involved, but I think this is a lot better than the internal turbine, because the internal turbine is like a submarine or like a jet turbine with the propellers, and you want to make it somewhat long, I'm guessing, because you're gonna have to probably put stabilizer fins front and back, top and bottom. This does the same effect, to turn and twist and tilt and up and down and side to side to match the flow of the current. The only problem is, if you only have a single anchor point, the propeller wants to turn, and it's going to want to turn the entire generator, forcing the stabilizer fin. Either you make the stabilizer fins bigger, and have the stabilized fins also adjust for the turn of the turbine, or you use impellers. The rotation of the impellers on the flat plane I don't think would affect too much, especially because you have two rotating in opposite directions. It'll probably stabilize itself. But anyway, I'm just trying to harness the power of the tide. To me, it's an untapped resource that they've been trying to tap for a while. I've seen underwater windmills. But to me, to construct them poses an issue underwater. I seen the boat from Switzerland. I want to say it's Switzerland, and they have the impellers. It's basically an upside down wind turbine or a water turbine. This is strictly for underwater use, and all you really have to do is this whole thing can be built outside. The only thing you're really constructing underwater is the base to anchor it. And I don't think it does cost too much to put a really big solid block of concrete and just sink it. Keep it simple. The more redundant and the more simple a system is, the more likely it will last, especially in the corrosive environment the ocean poses. Now, I'm sure materials and stuff to build this will probably be the hardest issue because of the corrosiveness of salt water. But I'm sure somebody smart will figure that out. Maintenance. What I think the maintenance would be, it would probably have some kind of buoyancy control, a way to float this thing. So to maintain these things, you would disconnect from the anchor point, bring it to the surface, maintain it, and sink it back down and re-anchor it. Be the simplest way to probably, instead of trying to do underwater diving, all that crap, never mind all that. Disconnect it from the anchor point and send it back up. The only real work you're going to have to do is re-anchoring it back to the anchor point. Well, anyway, drones out. I think I've thought about this enough.